Welcome students. In this class you are expected to answer this question. Let me read this question. Find the coordinates of the foot of the perpendicular drawn from a point 0, 2, 3 to the line. Now you got to understand this question. Now let me draw this line. This is the line. It is given as x positive 3 divided by 5 is equal to y negative 1 over 2 is equal to z positive 4 divided by 3. Now the directional ratios of this line is 5, 2, 3. So that's the first point. You need to write that down. Now the next point is we are expected to find the coordinates of the foot of the perpendicular drawn from a point 0, 2, 3. Now what is the meaning of this? Now imagine you have a point given by this coordinate 0, 2 and 3. Now from here you are taking the shortest distance. The shortest distance is actually the perpendicular distance. From this particular point you are drawing the shortest distance to this line. Okay, now you might be asking, why are we so much bothered if this point is P and this point is M? We are actually looking to get this particular point. We need this coordinate. As I mentioned to you, you might be asking me, why are we so much bothered about this particular coordinate? That's exactly what is required. Find the coordinates of the foot of the perpendicular. This is the foot. M is the foot of the perpendicular. M is the foot of the perpendicular drawn from this particular point 0, 2, 3. So as I mentioned to you, you might be asking me, why are we so much bothered about this M? Now what if I tell you this M can vary along this line? Now instead of this being 0, 2, 3, if I were to draw a perpendicular from another particular point hitting this line, and in this case this is going to be some M dash and this is going to be some P dash, and this P dash can be alpha, beta, gamma, delta, or alpha, beta, gamma, depending upon the dimensions we are talking about. In this case we are taking alpha, beta, gamma, and we want to know this particular M dash. Now this is a very important concept which are applied in drone technology. Now you might be wondering, where do I apply this? You are going to be applying this extensively in drone technology. Of course, you might have heard this example. Suppose you had to walk from this particular point to this line, then you have to find out the foot of the perpendicular. Of course, no matter how you walk, you're going to be hitting the base of this line. You're not going to be hitting the line somewhere over here. Now that hit was only possible with drones. Now imagine I have a drone and I'm interested in exactly measuring where the drone is capable of landing. Now the drone, when I say landing, the drone can hit anywhere along this line. And that is important to me, because if I were to create a drone for hitting the mosquitoes at a certain point, I'm interested in knowing not only this M, but I want to know this M dash, say some M double dash and some M triple dash, etc., so on and so forth. So that is a very important application that we will have to focus on. Okay, so much so. So foremost, let me give you the steps, because we have to do this thing from the examination point of view. So let me give you the steps first. So write down this. We start off by saying that given line is what? X positive 3 divided by 5 is equal to y negative 1 divided by 2 is equal to z positive 4 divided by 3. Therefore, the directional ratios of the given line is 5, 2, 3. Now we need to find what? We need to find the directional ratios of the line PM. What is PM? PM is the line This is for your understanding. Drawn from 0, 2, 3 to the point M, where M is the foot of the perpendicular. Okay, so as I mentioned to you, M is over here. So how are we going to get the directional ratios? So for that, let x positive 3 divided by 5 is equal to y negative 1 divided by 2 is equal to z positive 4 divided by 3 is equal to some lambda. So therefore the coordinates of M, we need to know the coordinates of the point. Coordinates of M is multiply 5 into lambda, right? You can write lambda, probably I'll write lambda like this. 5 into lambda, this 3 goes to the other side, will become negative 3. Then 2 into lambda, this negative 1 goes to the other side, become positive 1. Then 3 into lambda, this 4 goes to the other side, become negative 4. So this is the coordinate of M. Now we need to find the directional ratio. So therefore the dr associated with M is obtained by subtracting from this particular point. You got to subtract this point 0, 2, 3. So negative 0, 2 lambda plus 1, negative 2, and then 3 lambda, negative 4, negative 3. So what do you get? You get 5 lambda, negative 3, and 2 lambda, negative 1, and 3 lambda, negative 7. So this is what we've got. Okay, now for the line, because we are looking for the foot of the perpendicular, so that would mean PM should be perpendicular to the line. Okay, since we are interested in the foot of the perpendicular, this would mean PM is perpendicular to the given line, right? So that would mean the dot product of the directional ratios is equal to 0. So that in turn is going to mean we got to take the directional ratio of 5, 2, 3 and take the dot product with this equated to 0. That's exactly what I'm going to do. So this would mean 5 times of 5 lambda negative 3, positive 2 times of 2 times lambda negative 1, positive 3 times of 3 lambda negative 7 is equal to 0. Right, so let me check one more time. So this is exactly what we have got. Okay, so you take the dot product. So this is going to be 25 lambda negative 15 positive 4 lambda negative 2 positive 9 lambda negative 21 is equal to 0. Add these together. This is 29 and 9, that is 38 lambda. 15 and 7 2, negative 2 is negative 17. Negative 17, 21, this is going to be 38, negative 38. So negative 38 is equal to 0. So therefore 38 lambda is equal to 38. So lambda is equal to 38 divided by 38, which is equal to 1. So lambda is equal to 1. So that would mean the coordinate of the point M, coordinate of M, which is the foot of the perpendicular, is equal to 5 of 1 negative 3, 2 of 1 negative 1, 3 of 1 negative 7. So this is equal to, this is 2, 1, 3, negative 4. So this is the solution for this question. This is a lovely question. Please like, share and subscribe to our channel. Until we meet again. Thank you.